Hello and welcome to today's video. Today we're going to do a electrical installation certificate. They're all going, oh. It's the horrible part of the job. We'd all want to be out there doing installations, fault finding all the time, but I'm afraid we've got to do the paperwork from time to time. And unfortunately the electrical installation certificate, along with the EICR, are probably two of the worst ones that an electrician is faced with. Luckily, in Amendment 2, which is due out later this year, the amount of stuff in an EIC is being reduced. So the inspection part of it is being drastically reduced down, and it's going to be just concentrating on the test results. So that'll be good. As you'll see, the current section on the inspection is quite large. I think it runs over nearly 2 pages. And to be honest, it really does overlap with the EICR stuff. So, and some of it really isn't relevant to most of the installations that you'll do. Very quickly, I should mention there are 2 types of certificate that you can issue when you're out on site. One is this one, which is the electrical installation certificate, and the other one is a minor works. Otherwise known, the EIC is also sometimes known as a major works certificate. That's its old name. What's the difference between the two? Well, a minor works certificate would normally be issued if you're changing maybe just 1 or 2 circuits within a property, or maybe you're adding just 1 circuit. Sometimes minor works can still have an attached buildings control form to be filled in, depending if it's outside and so on. But normally minor works is to do with just bog standard stuff within a house. For example, you'd issue a minor works certificate if you added a socket to a ring final or something like that. That's what you would do a minor works for. The major works, or the EIC, which is the one we're going to cover today, is for, as it suggests, more major work. So the EIC that this is covering is the one where I had to go underground to run a cable into a garage. It's the one that my NAPIT assessment was done on. So those videos I'll put links to in the description. So this one would be covered by the major works. It has a buildings control form that has to be done along with it, and it's normally used when you're doing work in special locations, and like with this one where I'm actually running completely new circuits, or if you're doing a new consumer unit. That will obviously be a major works. So you can see the difference between the two. Let's go through it, and we'll cover all the different sections. So here's the form that we're going to be filling in. This is the EIC form that I do on the NAPIT Online system, but it's exactly the same as it would be for any other software, or if you did it on paper. It's exactly the same. The forms and the fields are exactly the same. So we're going to leave the top bit because it's a domestic property. I'm not going to do the installer reference or the client's name. That's for privacy, so we'll come to that later. So, and there are no comments on the existing installation, none covered by this, but there would be by the EICR, which is part of this on this occasion. Now, I'll come to this bit in just a second, but there are no records available, and according to the client, the last bit of work that was done was in 2019. So let's come back to this bit. So for work type, new, additional, or alteration. How I remember this is like this. Have you added a new circuit? Well, that's obviously a new. Have you added to an existing circuit? Have you added a socket or a light? Then it's additional. If it doesn't fall under those two, then it's an alteration. That's how I remember this. Okay? So in this particular case, it's obviously a new because we're doing all this work in the garage. So the description of the installation, we're going to fill in there. Give me just 1 second. Okay, so that's in there, and the extent of the certificate is, whoopsie daisy, that space extra. So that's effectively what goes in here. So you describe the installation and what's the extent of the installation. Okay, nice and easy. There are no departures from BS 76671. And there are no exceptions. In this particular case, we don't have to do a risk assessment, so that stays blank. And then in here I would enter my declaration about my installer, my position, and the date this was done. Next inspection. Now what I normally do for this type of thing is I will normally put in 5 years. It's up to your discretion. I don't recall there being anything in BS 7671 that actually states what it should be. It shouldn't be more than 5 or 10 years depending on what you're doing. For this I'd put in 5. If I was doing something where I knew that there were more issues maybe that elsewhere in the property, perhaps I might shorten that down to 1 year and come back the following year maybe, and things like that, but normally I'd stick it to 5. It's your real preference. I honestly don't think there's anything in BS 7671 that actually mandates that. So in this particular house it's a TNCS system, and this here you'll get from the meter box the cutout fuse, so that you will see it written down as a BS probably of 1361. In this particular case it's a type 2B, which I bet you isn't written here. No, it isn't, so you might have to add it. It's a type 2B. Now what's written on the outside of the fuse is a 100 amp fuse, so put that in there, and there were no other supply sources like solar panels. It's an AC supply. We've only got the one phase, and there are 2 wires, line and neutral. So down here, so you, as it says, you can, if you can't get the measurement, ask the DNO for these values. 9 times out of 10 you'd be able to measure these. There might be cases when you can't. A good example of this is if you cannot get to the supply cupboard in a block of flats. That's normally locked away in the bottom, and if you can't get hold of the landlord or someone to unlock that cupboard, you can't do it. So you'd have to get it by inquiry. However, in this particular case, I know that the voltage that I actually measured was actually 235, so I'm going to put down the measured value. The LPF came out, I've just lost it, it is at 0.61 kiloamps. Nominal frequency in the UK is 50, and the external loop impedance was 0.38. Now, just a quick note here, these readings were taken at the new consumer unit, not at the main unit in the house. Therefore, these values would be different from what you would do in the main house. Now, I checked this with my assessor the other day, and he said that's perfectly fine, that's perfectly valid. He said you could have done it in the main house and done it from there, but because I've done it from here, that's perfectly fine. For a TNCS system, that should be no more than 0.35 at the main consumer unit, but it will be higher if you've got another consumer unit on the system. Okay. I confirmed the supply polarity, and I didn't do the ZDB of the source of the circuit because I didn't take this reading at the main board. However, I might fill that in when I can now go back and do the EICR next week. I might actually fill that in as part of the EICR. Just to clarify, the assessor said the best way for me to do this, because I've done an EICR at the same property, is to issue these at the same time. Okay. So come on to the next page. So earthing in this case is at the distributor's facility. This is not a TT system. So none of that, or sorry, none of this is applicable. Now the maximum demand load I didn't do, that's perfectly fine, but you have to write it down as a limitation. And then we come on to the main switch, that which is in the main consumer unit, which is a 60947-3. It also had an 800 amp rating. Again, that's exactly the same. I don't know why we do that. Number of poles is 2. The voltage rating is 230 volts, and the location of this is in the main house. RCD is not used as the main switch in the main house, so that stays blank. So then we come on to the conductors. So the main earthing conductor is copper in this case, and it's 16 mil, and that's all been verified. The protective bonding conductors again were copper, and they were 10. I've verified that they exist. And the supply conductors again copper and 25. Okay. Now in this installation there was only bonding to the water pipes. There was no bonding to the gas because they were actually plastic pipes. You don't bond the plastic. So in this case, so the water pipes were verified, they existed, and it was all there, and it's fine. Gas, there wasn't any. Oil, there's no oil. There's no structural steel, and no lightning protection. So that's absolutely fine. So you don't have to worry about any of that. Now we come on to the section, the schedule of inspections. This is the section that is being changed, or being proposed to be changed, in Amendment 2. This entire section is being severely shortened. At the moment it runs to 2 pages, and I think it's an excellent idea. So the EICs in the future will mainly concentrate on the test results and the testing that's been done. It won't concentrate on the inspections. Okay, so this will very likely change in the next year or so, but at the moment, until Amendment 2 comes out, this is what you have to do. Now what I normally do when I'm doing this online at the very least is I pass everything to start with, and then I work my way down and change things as necessary. So the service cable passed, the service head passed, the earthing arrangements passed, meter towers, the meter equipment. There was not an isolator when I did this EIC. There is now, but not when I did this EIC, so it's not applicable. There are no parallel sources applied, so there's no solar panels or anything like that, so they're not applicable. And then we come down to the earthing arrangements. Distributed earth, yes. Earth electrode, no, because it's not a TT system. Earth conductor, yes. Main protective bonding, yes. Provision of safety electrical bonding, yes. RCDs, yes. In this case, basic protection. Installation of live parts, conductors completely covered, yes they were. Barriers and enclosures, correct IP rating, yes it was. It was metal, so it's to the 18th edition. RCDs present, they are. Supplementary bonding, there was in the bathrooms, so I've set that as pass. There were no self systems and no PELV systems. Double or reinforced insulation class 2 equipment, yes, and they passed. Electrical separation, no shaver units, so that's not applicable. So we're going there. Now on the consumer unit. Access, fine, as you saw in the video. Components are suitable, yes they are. Presence of linked main switches, yes. Isolators, that's basically MCBs and things like this, not the isolator from the main fuse. Yes it was. Suitability of enclosure, yeah it's fine, wasn't damaged in any way. Protection of mechanical damage, yep, not a problem. Confirmation all conductors connections are correctly located, yes. This was the one I had to talk to my assessor about. He said if I'm doing the EICR and doing the remedial work, this is why, he said, issue this at the same time as the EICR. So when I actually do the remedial work and check and change this, if you look at the EICR video that's in the description for this installation, you will see that that failed the EICR. But in this case, I'm going to pass it because I'm changing that to make it pass the EICR. Okay, so this is passed in this case. Selection of correct type of circuit protective devices, yep, that's all absolutely fine. Presence of appropriate circuit charts, there wasn't, and there isn't at the moment. Warning notice of method of isolation, yes. Oh, hang on, sorry, I do apologise. That's not applicable. Periodic inspection and testing notice, there will be when I've done it. RCD 6 monthly test notice, there will be when I've done it. AFDDs, there aren't any AFDDs, so that's not applicable. Warning notices, that will be there when I've done the EICR. It's not there on the main board at the moment. It is on the sub board that I did. Presence of labels to indicate the approach to the switchgear, that's not applicable. Right, we're on to the circuits now. You can see why they're getting rid of a lot of this in Amendment 2. Adequacy of conductors, yes. Cable insertion method suitable, yes. Segregation, separate, that is not applicable. Cables correctly corrected and supported throughout with protecting its abrasion. I'm going to put down not applicable. Again, I asked the assessor about this. I haven't seen this because it's in the walls, so I don't know. Again, same as 8.5. I don't know. I can't open up the walls to have a look. Non-sheath cables enclosed throughout the conduit. Well, the only place that exists is my stuff that I've just put in. So that would pass. Cables concealed under floors, yes. Cable conductors correctly identified by colour, yes. Presence, adequacy and correct termination, yes. Cables and conductors correctly connected, yes. No basic installation of clothing, nope. That's fine. Single pole devices, yes. Accessories not damaged, correct. So, provision of additional protection requirements by RCD. Sockets, yes. Suppliers of mobile equipment, that is not applicable. Cables concealed, we don't know, not applicable. Cables concealed walls, that's not applicable because there are no metal parts in the walls. Final circuit supplying luminaires within domestic household premises, yes. Presence of appropriate devices for isolation, means of switching off and mechanical maintenance, yes. Emergency switching, yes. Functional switching, yes. Firefighting switches, not applicable in this case. Current using equipment that's permanently connected, okay. Now normally this would relate to commercial and industrial premises, so we'll check it anyway. That's not applicable. That's not applicable. That's not applicable. And that's not applicable. Okay, so in this case for a domestic environment, that's nothing there. Sometimes maybe in a domestic environment, maybe for a workshop, you might have permanently connected equipment, but in this case we don't. Now there is a bathroom shower in there. There are no low voltage circuits, so actually that is not applicable for this particular certificate. And then we come on to schedule of test results. So again, I normally tick it all and then go down and change what I need to. Is there an earth electrode? No, because it's not a TT. Did I do LPF? Yes. Did I do earth conductors? Yes. Did I do protective conductors? Yes. Did I do ring final conductors? No, I did not, because there isn't a ring final connected with this certificate. Okay, only radials. Continuous protective bonding conductor, yes. Volt drop verified. I did do the volt drop. Insulation resistance, yes. Insulation resistance, yes. Polarity, yes. Polarity, yes. Earth, yes. RCDs, yes. Functional testing, yes. Functional testing, AFTDs, nope. Want any. And then I'd go in, put in my name in and the date, which it wouldn't be, that's today's date, but yeah, I'll put in the date when it's done. Okay, so now we come on to the boards. Now in this particular case, I'm going to add a DB, and I'm actually going to label it DB3. The reason for that is there are actually 3 distribution boards. There's the main board, there's another board in the conservatory, and the board I've put in. So this is DB number 3. Okay. When I do the EICR and finish that, I will label them DB1, 2 and 3 so everyone knows which one I'm talking about. So the location of this new DB is the garage. And there are 2 ways that I installed. Tested by and position held, I will put in, the date I'll put in, all the values are being taken from the on-site guide. Test equipment, serial number. It was the same piece of test equipment, so same piece of test equipment did everything. Just that. I'll then fill in all the test dates. Now this is where I need to do this because this DB is not connected directly to the supply. So this DB took its supply from the main house. It is single phase. It's connected to a type B breaker in the main building. A 60 898 BSEN. The nominal voltage is 230 and the rating of that breaker that it is actually connected to is 32 amps. Supply polarity is confirmed. It's single phase. Should you or should you not tick that box? I normally leave it blank if I'm just doing single phase because I can't confirm the phase sequence. There you go. So the LPF we've already filled in, so we'll do that again. So the LPF for this was 0.61, the ZDB was 0.38. Now the operating times of the RCD, that is relevant because it is connected to an RCD in the main house. So the RCD values, if you just bear with me just a second, just need to find my notes, there we go, was 40.8 at 1 times and 13.6 at 5 times. Now the BSEN of the RCD was that, number of poles it has 2. Oops. It's a 30 milliamp RCD and there's no time delay. Down here, vulnerable to damage. Lighting circuits in garage must be prior to IR tests at 500 volts. It's an LED light. You shove 500 volts D through it, it'll never work again. Right, so that's the board done. Now we're going to come on to the 2 circuits that we've... Actually, there are 3, because you've also got the circuit that's coming from the main board. That is considered a circuit. Even though it's going through a main switch, it is coming from a 32 amp breaker. So you have to add it. So, circuit tests. Here we go. So we're going to come down. It's the circuit designation is a. Let's just come down here. We'll just pick one. We'll call it garage for circuit designation. It's circuit number 1. Now the wiring type is actually down the bottom of this list. Some forms don't actually have this. Some software doesn't have this. This one does, so we do have to add it in. Now the cable, the Doncaster cable that I use is actually an XPLE cable. So it's type G that goes in there. Now, the reference method for XPLE cables and SWE cables is both identical. It's reference method 1. And it isn't here, so you have to add it. Okay. All the other reference methods are to do with PVC cabling, to an earth and so on. There are, on this, hanging off this, there are actually 2. Yep, there are actually 2 points. You've got the lighting circuit and you've got the socket circuit, so there are actually 2 points coming off this. The line conductor for this was 4 mil. The CPC within that was 1.5. The disconnection time is 0.4. You can find this in the on-site guide and in BSM61. It'll tell you what the disconnection times are for these type of installations. Over current protective devices, it is a 60898. It's a type B in the main house and it's a 32 amp rating. All type Bs have a 6 kiloamp breaking capacity. The RCD operating count is 30 and the max ZS for a 32 amp breaker is, just bear with me 1 second, I'll just get my notes for this. Just bear with me, it is 1.1. Okay. Now this isn't a ring final, so all of this stays blank. We don't do a figure of 8 check on a radial, because that's what this is. So the R1, R2 reading for this circuit, and I've lost it again, where's it gone? With 0.1. The installation resistance was done. It was at greater in my QTech tester. It does it displays greater than 2000. So that's what it. No, sorry. That should be 500. I do apologise. This should be greater than 2000. If it wasn't, I would be hugely annoyed and surprised, as it was a brand new cable. So it should definitely have been this. Anyway, so that's the installation resistance. Polarity was definitely taken, and the maximum measured ZS is the 0.1 added to the 0.38. So that is 0.48. Well within the 1.1. It's absolutely fine. And we're going to fill in again the values for the RCD. 40.8 and 13.6, and we tested the RCD button. There is no AFDD, so we leave that blank. So we don't need to worry about any of the rest of it. So that is the first circuit done. So next circuit, we'll do the socket radial next, and we'll come down here, socket radial. There we go. Now the wiring this time will be type A. No, it isn't. I do apologise. It isn't type A. It is type. I've lost it. It's type C. PVC cables in non-metallic conduit. Okay, because I put singles in PVC conduit. So it's actually. Let's have a look here. Yeah, it's type C. So the wiring type is type C, and the reference method for that is its reference method B, which is conduit on the wall, which is what it is. There's only 1 point from it. The line conductor was a 2.5 and the CPC was a 1.5. Disconnection time, as before, is 0.4. It's a 6898 breaker, type B. The rating is 20 on this one. The braking capacity is 6. The operating current again is 30. The max ZS for a 20 amp breaker is 1.75. Again, it's not a ring final, so we don't do any of that. And the R1, R2 for that, it's very, very short, is 0.02. Test voltage again was 500 for the installation resistance, and again exactly the same results. Polarity was checked, and the maximum ZS in this case was 0.4, 0.38 plus 0.02. Again, well within the limits. And again, we have to repeat what the RCD values were, which were 40.8 and 13.6, and the RCD was tested on the test button. So we come to the final circuit for this, is with the lights. There we go. So the wiring type, in this case is type A because it was just to an earth. The reference method is C, which is clip direct, and there was one lighting point. It was 1.5 for the line and 1 for the CPC. Disconnection time of 0.4. BSEN is 6898. Type B again. This time had a rating of 6 and a braking capacity of 6. The RCD's operating current was 30, and the max ZS for a 6 amp breaker is 5.82. Again, it isn't a ring, it's lights are radial circuits, and in this case the value was, I'm trying to find it, it was 0.12. Again, the test voltage, which I did before I connected the light up, came out to this. Again, I'd be hugely surprised if it didn't. And in this case, we are going to come out at a point maximum measured ZS of 0.5. And a 0.12 there, 0.38, that's 0.5. And polarity was checked as well. We are well within this. Okay. Again, I was doing short cable runs. If you were doing long cable runs within a house, yes, you could get what, maybe up even as far as halfway to this score. Okay. So RTD finally 40.8, 13.6, and the RCD was tested. Now, it doesn't mean to say I did this RCD test 3 or 4 times. I only did it once. Didn't need to do it 3 or 4 times. Okay, so that's it. That is that form completed. And I can just go to preview. A little bit of blurb at the front. Then obviously all of this would be filled in. Skip to section 3. So there's section 4 all filled in. There's section 5 all filled in. And then we come to the inspection part of it, and this is where you see it goes over 2 pages. And then finally you've got your test schedule, which is here. So there you go. The worst part of that form is the inspection section. I am so pleased that Amendment 2 looks like it's going to shorten that considerably, because then you get on with what you're supposed to be doing, which is getting the test results done. That's what this is for, is registering all those test results, and everything else to do with the installation. Obviously, minor works one is a lot simpler. For a start, you don't have the inspection section altogether. It only has room for 1 circuit. That's what it's really designed for. So if you have more than 1 circuit, then you kind of have to make a decision: do I do 2 minor works or do I do 1 of those? I know which I would do. I would do 2 minor works. Cut and paste. Anyway, I hope that's a bit useful. I must admit, while doing the paperwork is very daunting for somebody who's never done it before, and it comes with practice. The more times you do that, it goes in and you know exactly what you're doing, you know what to be expected to see, and everything else. The fuse, I'll tell you what, the fuse types can be different quite a bit. On this particular occasion it was a type 2B, as you saw. I've seen all sorts, so I don't take things for granted when I go into houses. I don't just blindly go and cut and paste that section, because sometimes those fuses are actually completely different types with different BSCN numbers on them. Same with the main switches. Just because the main fuse is 100 amps, it doesn't mean to say the main switch is. And I've seen a lot where the main switch actually isn't. In fact, it's more common for me to find main switches that aren't a match for the main fuse than when they do match. Anyway, there we go. I hope that's been. I hope it's been useful. Any questions? Stick them in the comments, and we'll see what we can do about answering them. Okay, and we'll see you on the next one.